this is really the format. It's x minus c all squared. So when you see a minus, it's moved to the right. If you see a plus, it moves to the left. Okay, that's the bottom line. That's all you got to remember. So this graph would actually go 2 units to the left. And so if we move this 1, 2, you'd have a vertex over here now, right? And it'd be like, oh, I said right and I moved left. Thank you. Thank you very much. Yeah, so we're moving to the right. Straight lines. Okay, x minus 2 moves to the right. Get that right. Over 2, up 4, right? 2 units to the right, and so on. So here's your second sort of mirrored sketch there, right? So that's the c value, and then the d value. What does it do? D value is the function. The d value does what? Moves it in the vertical direction, right? And so what does a plus mean? Is that up or down? Yeah, it's outside the brackets. The format is plus on the end, so this goes up. So now let's see. Let's do like black. Okay, so here we go. Over 2, up 4, 2, 4, right, and so on. And so we have this as our transformed function. Okay, so the black one would be the final sort of version of this. So how are we doing there? Everybody good with that? Okay, good, good. You noted my left-right mistake, so that's good. You guys are on the ball. So the good thing about this section is that we're doing exactly the same things. It's exactly the same things, except with sine and cos. So we're stretching them vertically, stretching them horizontally. We're moving them left or right, and moving up and down. It's maybe a little bit trickier when you're talking about sine and cos because they are periodic functions. So they kind of, the waves go, forever. And so moving them left, right, they start to map on themselves. So you kind of, there's a little bit of, you got to be careful there, right? Because if we move a sine graph over, it maps exactly like a cos graph. So anyway, so you'll see that how that works. But okay, so what I want to show you here is that a regular sine graph, and I'm not going to probably draw anything here, but this is a regular sine graph, and we know that A is 1. We know that B is also 1, right? So that's 1 theta. The C value, what is the C value for just this regular sine theta graph? What's the C value? 0, right? Minus 0. Because we don't move it left or right, because there's nothing here. And what about the D value? 0 as well. Okay? So on a regular graph, A is 1, B is 1, and C is 0 and D is 0. So we don't move left or right or up or down. So on a typical graph, those are the values there. A is 1, B is 1, C is 0, and D is 0. Okay? Okay. So yeah, so I'm not going to draw a graph here right now, just for time's sake. I'm going to keep on moving here. But I will sort of talk to you about this sort of thing, okay? If you have a graph like this, y equals sine of pi theta plus 3 pi, and let's say this is all inside the brackets here, okay? It's all inside the brackets. What we're going to need to do is to make sure that we have factored this binomial, okay? Because I don't know if you guys remember, you hopefully remember from the first chapter there when we did the transformations. If there's a binomial in here, you have to factor that out to see what b is and to get the right c value. So in this case, this is what we would have. Okay, forget about that plus 1. So pi theta plus 3 pi. Pi is the common factor there, so I would remove pi, and I would have theta plus 3. This is my variable theta. And so what we notice here is that pi is the b value, and 3 is the c value. Okay? And again, we would look at the sign as well. And so this moves 3 units left. That's what it says that we have to do to a regular old sine graph. And this says that the period length is 2 pi over pi, or the period length is 2. Okay? All right. So if we were to graph this, and I think I want to tackle this now. 3 units left. So let's do this. I'm going to try and use this graph paper, but my lines are going to be garbage. Tough to do on this tablet, right? Actually, I tried this morning too to fix these lines, and they don't actually make them straight. I don't know why. Let's see if it works this time. What? Tools. Oh yeah, actions. There we go. Make that a line. Look at that. Still not even a straight line. Don't get it. But anyways, that's a little bit straighter. Change shape to a line, and that's sort of a line. Thank you. Okay. Okay. All right. So the parent. What's the parent function here? It's sine or cos. It's going to be sine or cos, so it's sine, right? So what I would suggest you do, and again, this is the kind of the beginning of the graphing stage. Okay. How do we graph these? Graph the parent function first. All right. Now notice that the period length is going to be in non-pi units. This is just decimals. Okay. So what I'm going to suggest that you do is to write this in decimals, in numbers here, not pi or anything like that. So let's make this 1, 2, 3, 4, 5, 6. And so 2 pi in decimals is about 6.28, right? So it's going to be about here. That's 6.5, this is about 6.28. What's pi as a decimal? 3.14. So the parent function, let's make 1 up here somewhere. Okay, and there's -1 down there. So again, this might look a little strange, but this is just decimal form of pi. And the reason why I'm doing that is because our period length is 2. So that's just going to be easier if we just work with decimals, because that's really a decimal. It's not in terms of pi. All right, so we're going to half of this, half of 3 is about 1.5 something. So there's halfway in between there, there's halfway in between there. And if we sketched it out, this is going to be kind of high, but this would be like this. Okay, down to 3.14, that's pi there. And okay, so there's our sketch of sine with the horizontal axis in decimals. And this is y equals sine theta in purple. Okay? You guys all good with that so far? Does that look okay? No major complaints? Alright, if we... okay, so let's move... When we do our transformations, let's apply them left to right. So A is 1. B, we said, was pi. That translates into a period length of 2. Okay? So right now our period length is 6.28. Alright, so the period length has got to be 2 units. So here's 2 units right here. Okay? So the b value is pi, or 3.14. And so that means that the graph is going to get squished up, right? Because it's greater than 1. And so we see that here it's getting squished up quite a bit. So if you're going to graph this, it's going to be kind of a tall graph, but we have to sketch it now like this, going up and then coming down. Yeah, I made that 1 unit quite high, but I think that works pretty good. So that's a period length of 2 instead of a period length of 2 pi. Period length of 2, 2.0. Just 2. Are you okay with that so far? See what the b does? Right? Okay. And then we got to go 3 units to the left, so that means we take every point on this last one that we just did, and let's change color to light orange. You guys see light orange, okay? Does that show up? Okay. All right, so that means every point here we got to go 3 units. So let's see if I can do it. It's -1. There's -2. There's -3. And so each point, this one, goes over 3 units. This one up here, which was at a half, goes over 3 units. So it's -2.5. Same height, 2.5. -2.5. So everything goes over 3 units. 1 comes back to 2, and so on. 2 comes back to -1. This one, 1, 2, 3. And so our final graph here would look kind of like this. And a good idea, I know you can't change colors so easily, but if you can draw all of them kind of dotted and then the last one do it like a solid line. And that's one period, drawing one period of this graph here. Okay, so it starts off with the purple, gets transformed, and then squished up and then moved over. Okay, so let me erase some of this goop here. Everybody see what we just did? Okay, now, instead of starting a brand new question, let's add D. This is going to be super easy. Add a D. So let's put a D value in here as, let's say, let's do like a -2 maybe. -2. So here's our whole function now. We're going to now draw this, and let's draw that in dark blue. Okay. So the A value is 1. We got that. It's an amplitude of 1. The B value, we calculated our new period length. The C value, we've moved everything to the left 3 units. And now we need to move this graph down 2 units. Oh yeah, actually I'm going to be in trouble, aren't I? Because I made this 1 so high. Oh, that's too bad. So let's see, this would be 1, and then 2 would be somewhere way down here. Okay, let's just fake it. Let's put it right here. Okay? That's it. Let's say this is 2. Not exactly, but 2 units down. Okay? And 1, 2, 3, 4, 5, 6 squares. So 1, 2, 3, 4, 5, 6 squares. So over here. And you kind of get the picture, okay? So sorry I don't have quite enough graph, but it would look like this. You just move everything 2 units down. Alright, so kind of go like that. And then this would be your final graph down here. You simply just move it 2 units down. Okay? Alright, so again, the parameters, you apply them just kind of one at a time, and you're able to graph, you can graph your new graph. Questions? Okay, I think you guys are pretty good at that. Probably the trickiest part here would be to determine an equation from a graph. Okay, so here are some notes too that I don't know if you need to write down. You should know this already, but a horizontal translation is also called a phase shift. You might see it as phase shift.